In section 2B, we're going to look at solving by completing the square. And this is, you haven't done a whole lot of this. Completing the square is different now. We just looked at setting equal to 0 when we wanted to solve by factoring. And when we get to the quadratic formula, you'll have to do that as well. Completing the square is a little bit different. So let's take a look here at number 40. Now, we're not going to do factoring, we're going to complete the square. And to complete the square, some rules you have to have. You need your quadratic term, or your x squared or p squared, on one side, along with your p term, or x term, or variable to the first power, and you need your number term on the other side. So if we're going to factor this, this is in the right form, but when we complete the square, we need to move that 55 over to my other side. I'm going to move this over a little bit. So here's the form I have. I have p squared minus 16p, and I'm going to leave a little space here and put my equal sign equals negative 55. Alright, here's the rule. We want to get this side eventually to a perfect square where we can take the square root. And this is what we're going to make this into a trinomial. So we're going to add something here to make that a perfect square trinomial that I can write as a binomial squared. And here's how you do it. You go to the b value, the thing in front of p, and it's negative 16. You take half of negative 16, or half of whatever it is, which is negative 8, and you square it. So what's negative 8 squared? 64. So what I want to do is, I want to take that 64, and I want to put it here, and I'm going to add 64. Because I can basically, so if I looked at factoring this trinomial right here, it would factor into p minus 8 and p minus 8. Okay, well, really what goes in there with the p is the minus 8. So, if you factored this as p minus 8 and p minus 8, and I kind of skipped this step, but we can write that as p minus 8 squared. Okay, so really the shortcut is don't even write it like that. You're going to put your p in your binomial, and then whatever it is you squared to get the number you added here is going to go right in here in the binomial. Now, when we add 64 to the left, we have to add 64 to the right. Because what you do to one side of an equation, you have to do to the other. So now we're going to combine these two, negative 55 and 64 on this side, and I get 9. So now the rule is I got to solve for p, and I have this binomial squared, p minus 8 squared. I want to take the square root of both sides, because that will undo the squaring. So p minus 8 equals, now in an equation, when you do the square root of something, you need a positive and negative square root of 9, okay? But really, square root of 9 is 3. Now this one ends up being a perfect square here. That doesn't always happen that that's going to be a perfect square. And then how would I get p alone? Well, I want to add 8. And here's what you want to do, because sometimes you're going to be left with a radical over there that you have to simplify. I would suggest when you get rid of this on this side that you add it in front of the plus minus sign. So it's p equals 8 plus or minus 3. Now, when this term right here is not a radical, you can go ahead and separate this into two things, and I can do 8 plus 3, and I can do 8 minus 3, and that's going to give me my two answers, or two solutions to the quadratic. So this would be 11, and this would be 5. So it's 11 and 5. Now, just to point something out, if I went through this and solved by factoring, p squared minus 16p plus 55 equals 0, and I did my product of 55, sum of negative 16, and I factored it, I would also get 11 and 5. This is just a different method. And you have to use completing the square when I tell you to use completing the square to show me that you know this method.